A box of mass 5 kilograms rests on a smooth surface that is inclined at an angle of 40 degrees to the horizontal. Two external forces are applied to hold the box in equilibrium. These are a force of magnitude 25 newtons, that is parallel to the slope, and a force of magnitude F newtons at an angle theta degrees to the slope, as shown in the diagram. The normal reaction force between the box and the slope is of magnitude 30 newtons, and that is not shown on the diagram. Calculate the angle theta degrees and the magnitude of the force F. Hello everyone. So how do we proceed with this question then? Well, we have got two unknowns that we're asked to find. We're asked to find a force and we're asked to find an angle. Those are the two unknowns here. Now you would have learned very early on in your maths career that if you've got one equation and one unknown, then you can solve that equation and find the unknown. However, if you've got one equation and two unknowns, you cannot use that equation to find the unknowns. You can't find the unknowns given that limited information. But if you've got two linked equations called simultaneous equations with two unknowns in each, then you can solve the equation simultaneously to find the unknowns. A procedure you are familiar with. And it's the same thing with this question. We need to find two simultaneous equations with two unknowns. That is our direction of travel here. How do we get there then? Well, this is a force question. So we use Newton's laws, and we are told in the equation the block is in equilibrium, or the forces are in equilibrium. If the forces are in equilibrium, then in all directions, and that's an infinite number of directions, the sum of the forces along any one of those directions has to equal 0. That is the law. So the sum of the forces along any direction has to be equal to 0. Now we need two directions, and they have to be at right angles to each other, because if they're right angles to each other, then they're not interfering with each other in any way. They are completely independent, but nevertheless linked. And those two force expressions and those two directions that are right angles to each other will form our two simultaneous equations. So this is our starting point. We call the two directions x and y. So we're looking for some of the forces in the x direction have to be equal to 0, and some of the forces in the y direction that's the right angles to the x direction also have to be equal to 0. In other words, so what should these x and y directions be? In other words, what should our coordinate system be that we will use to solve this equation? Now the rule is this: if you've got a body that's accelerating, we choose the directions, one of the directions, to be along that direction of acceleration. Now nothing's accelerating here, but the implied motion is along the slope. That's the implied motion. So that's the direction we should choose, and I'm going to call that the x direction, and the other direction should be perpendicular to it. So that's my coordinate system that I have drawn there, and there's an angle 40 degrees. Now the next thing I must do is put my 5 kilogram mass at the origin of that coordinate system and draw all the forces acting on the mass. And you can see the 30 Newton normal force drawn as well. That's not drawn in the diagram, but that's it there. That's the force the slope exerts on the body. mg is the force the earth exerts on the body, called its weight. And the other two forces are included as well. And that's our force diagram on the coordinate system. Next thing we must do is note the forces that are not aligned to the coordinate system have to be resolved along the coordinate system. So the mg force is acting vertically downwards, always acting vertically downwards, is not aligned to the coordinate system, and the F force at an angle theta is also not aligned to our coordinate system. So they have to be resolved along that coordinate system. So we've got the f, so that's simple enough. Down the slope in the negative x direction is mg sine theta. That's the body's weight down the slope. And mg cos theta is the resolved force down the y-axis in the negative y direction. And the F force, well, you've got F cos theta in the positive x direction, and you've got F sine theta in the positive y direction. Then I've colour coded this, and the forces of the same colour have to be added together to give you 0, and the forces of in the red colour will also have to be added together to give you 0. And those will form our two sets of simultaneous equations. Now when you've done that, you have done the physics of the problem, or the mechanics of the problem. After that, you're simply solving simultaneous equations to get your f and your theta, and that's done. That is there, and it's done for you.